Hyperspace, Summary and Review. Michio Kaku's Hyperspace, 1994, is a captivating exploration of the frontiers of theoretical physics, specifically focusing on the concept of higher dimensions beyond our familiar three spatial dimensions and one time dimension. The book delves into the history of these ideas, explores their implications for our understanding of the universe, and speculates on the potential for future technological advancements based on these theories. Part 1: The Geometry of the Universe. Chapter 1: The Fourth Dimension. Kaku introduces the concept of higher dimensions, beginning with the fourth dimension, time. He explains how Einstein's theory of relativity unified space and time into a single four-dimensional continuum. Chapter 2: The Fifth Dimension. Kaku delves into the theoretical possibility of a fifth dimension, which could explain the existence of parallel universes. He explores Kaluza-Klein theory, which suggests that the fifth dimension is curled up into a tiny circle, invisible to us. Chapter 3: The Sixth Dimension. The sixth dimension is introduced as a realm where all possible worlds exist, each representing a different configuration of the universe. Kaku explains how this concept could be used to understand the origin of the universe and the nature of its fundamental constants. Chapter 4: The Seventh Dimension. The seventh dimension is described as a space where all possible universes with different fundamental laws of physics exist. This concept opens up the possibility of exploring the multiverse, where an infinite number of universes exist with different physical laws. Chapter 5: The Eighth Dimension. The eighth dimension is presented as a space where all possible histories of the universe exist. Kaku explores the implications of this concept for understanding the nature of time and the possibility of time travel. Chapter 6: The Ninth Dimension. The ninth dimension is described as a space where all possible mathematical structures exist. This concept suggests that the universe itself could be a mathematical construct, and that our understanding of reality is limited by our ability to comprehend higher dimensions. Chapter 7: The Tenth Dimension. The tenth dimension is presented as a space where all possible universes with different mathematical structures exist. This concept challenges our understanding of reality and suggests that the universe is not just a physical entity but also a mathematical one. Part 2: The Physics of Hyperspace. Chapter 8: The Theory of Everything. Kaku explores the quest for a unified theory of physics, which would explain all the fundamental forces of nature. He discusses string theory, which suggests that the universe is made up of tiny vibrating strings that exist in 10 dimensions. Chapter 9: The Superstring Revolution. Kaku delves into the implications of string theory for our understanding of the universe. He explains how string theory could provide a framework for understanding the origin of the universe, the nature of black holes, and the possibility of time travel. Chapter 10: The Birth of the Universe. Kaku explores the Big Bang Theory and how string theory could explain the origin of the universe. He discusses the concept of inflation, which suggests that the universe underwent a period of rapid expansion in its early stages. Chapter 11: The End of the Universe. Kaku examines the various possible scenarios for the end of the universe, including the Big Crunch, the Big Freeze, and the Big Rip. He explores the implications of string theory for understanding the fate of the universe. Chapter 12: The Quantum Universe. Kaku explores the nature of quantum mechanics and its implications for our understanding of the universe. He discusses the concept of quantum entanglement, which suggests that particles can be connected even when separated by vast distances. Part 3: The Future of Hyperspace. Chapter 13: The Hyperspace Engine. Kaku explores the possibility of building a hyperspace engine, which would allow us to travel faster than the speed of light. He discusses the theoretical concepts behind such an engine and the challenges that would need to be overcome. Chapter 14: The Time Machine. Kaku examines the possibility of time travel, exploring the theoretical concepts behind it and the paradoxes that it presents. He discusses the potential for building a time machine and the ethical implications of such a technology. Chapter 15: The Universe in a Nutshell. Kaku concludes the book with a summary of the key concepts and implications of hyperspace theory. He emphasizes the importance of exploring the frontiers of theoretical physics and the potential for future technological advancements based on these ideas. Overall, Hyperspace is a thought-provoking and accessible exploration of the frontiers of theoretical physics. Kaku's clear and engaging writing style makes complex concepts understandable for a general audience. The book offers a glimpse into the future of physics and the potential for groundbreaking discoveries that could revolutionize our understanding of the universe. While the concept of hyperspace travel is fascinating, it's important to acknowledge that it currently exists solely in the realm of science fiction. There are no known scientific breakthroughs that could definitively enable hyperspace travel as depicted in popular culture. However, some theoretical concepts in physics could potentially lead to faster-than-light travel, though not necessarily in the way hyperspace is often portrayed. These include 1. Warp drive. This concept, popularized by science fiction, involves manipulating spacetime itself to create a warp bubble around a spacecraft. The bubble would essentially compress spacetime in front of the ship and expand it behind, allowing it to travel faster than light relative to the surrounding universe. Challenges. The theoretical framework for warp drive requires exotic matter with negative mass-energy density, which has never been observed. Additionally, the energy requirements for creating a warp bubble are immense, potentially exceeding the total energy output of our Sun. 2. Wormholes. These hypothetical tunnels through spacetime could connect two distant points in the universe, potentially allowing for faster-than-light travel. Challenges. Wormholes are highly unstable and require exotic matter to remain open. They are also predicted to be extremely small, making it difficult for a spacecraft to pass through. 3. Quantum entanglement. This phenomenon, where two particles become linked regardless of distance, could potentially be used for instantaneous communication. While not directly related to travel, it could theoretically be used to control a spacecraft remotely, effectively allowing for faster-than-light communication. Challenges. Quantum entanglement is still not fully understood, and its potential for practical applications is still being explored. 4. String theory and extra dimensions. Some interpretations of string theory suggest the existence of extra dimensions beyond our familiar four. These dimensions could potentially be used for faster-than-light travel, though the exact mechanisms are still highly speculative. Challenges. String theory is still a theoretical framework, and its predictions have not yet been experimentally verified. It's crucial to understand that these are just theoretical possibilities, and there's no guarantee that any of them will ever be realized. The challenges associated with each of these concepts are significant, and overcoming them would require breakthroughs in our understanding of physics that are currently beyond our reach. In summary, while hyperspace travel as depicted in science fiction remains firmly in the realm of fantasy, research into these theoretical concepts could potentially lead to new forms of faster-than-light travel in the future. The theoretical concepts of hyperspace challenge our current understanding of the universe in several profound ways. 1. Expanding the dimensions of reality. Our current understanding of the universe is based on a four-dimensional framework, 3 spatial dimensions and 1 time dimension. Hyperspace theory proposes the existence of additional dimensions beyond our perception, potentially up to 10 or more. This fundamentally alters our perception of reality, suggesting that our universe might be a mere slice of a larger, multidimensional reality. 2. The multiverse and parallel universes. Hyperspace theories, particularly those involving higher dimensions, suggest the existence of multiple universes, either as parallel universes existing alongside our own or as different configurations of the universe within a higher dimensional space. This challenges the notion of a singular, unique universe and opens up the possibility of other realities with different physical laws and histories. 3. The nature of time and causality. The concept of higher dimensions, particularly the 8th dimension, challenges our understanding of time and causality. Hyperspace theory suggests that time might not be linear but rather a multidimensional concept where all possible pasts, presents, and futures exist simultaneously. This could have profound implications for our understanding of free will, destiny, and the possibility of time travel. 4. The role of mathematics in reality. Hyperspace theories, particularly those involving the 9th and 10th dimensions, suggest that the universe itself might be a mathematical construct. This implies that the laws of physics and the fundamental constants of the universe are not arbitrary but rather emerge from the underlying mathematical structure of reality. This challenges our traditional view of the universe as a purely physical entity and suggests a deeper, mathematical underpinning. 5. The limits of human perception. The existence of hyperspace and higher dimensions implies that our current understanding of the universe is limited by our perception, which is confined to the 4 dimensions we experience directly. This raises the question of whether we can ever truly comprehend the full extent of reality or if there are aspects of the universe that remain forever beyond our grasp. 6. The potential for new physics and technologies. Hyperspace theories, particularly string theory, offer a framework for unifying the fundamental forces of nature and explaining phenomena like dark matter and dark energy. They also suggest the potential for developing new technologies, such as hyperspace engines and time machines, that could revolutionize our understanding of the universe and our place within it. Overall, hyperspace concepts challenge our current understanding of the universe by expanding our perception of reality, suggesting the existence of multiple universes, questioning the nature of time and causality, and hinting at a deeper, mathematical underpinning of the universe. These concepts offer a glimpse into a vast and complex universe that is far more intricate and fascinating than we currently comprehend. The philosophical implications of multiple universes, as proposed by hyperspace theories, are profound and far-reaching, impacting our understanding of 1. Uniqueness and meaning. The existence of multiple universes challenges the notion of our universe's uniqueness and our place within it. If there are countless other universes with different physical laws, histories, and even different versions of ourselves, does our existence hold the same significance? Does our universe have a special purpose or meaning if it's just one among many? This raises questions about the nature of meaning and purpose in a vast and potentially infinite multiverse. 2. Determinism versus free will. The concept of parallel universes, where different choices lead to different realities, raises questions about determinism and free will. If every possible outcome exists in a parallel universe, does that mean our choices are predetermined, or do we truly have free will to shape our own reality? This philosophical debate becomes even more complex in the context of a multiverse, where the boundaries between different realities might be blurred. 3. The nature of reality. The existence of multiple universes challenges our understanding of what constitutes reality. If there are countless other realities with different physical laws and constants, what defines the real universe? Is our universe the only true reality, or are all universes equally real? This raises questions about the nature of existence and the criteria for defining what is real. 4. The anthropic principle. The existence of multiple universes could explain the fine-tuning of the physical constants in our universe, which seem perfectly suited for the existence of life. The anthropic principle suggests that we observe these fine-tuned constants because we exist in a universe where they are suitable for life. However, if there are countless other universes with different constants, it becomes less surprising that we happen to exist in one where life is possible. 5. The limits of human understanding. The concept of a multiverse suggests that our understanding of reality is limited by our perception and our ability to access information from other universes. This raises questions about the limits of human knowledge and the possibility of ever fully comprehending the true nature of reality. 6. The search for meaning and purpose. In a multiverse, the search for meaning and purpose becomes even more complex. If our universe is just one among many, what is our place in the grand scheme of things? Does our existence hold any inherent meaning, or do we create our own meaning through our actions and experiences? Overall, the philosophical implications of multiple universes are far-reaching and profound, challenging our fundamental assumptions about the nature of reality, the meaning of life, and the limits of human understanding. It forces us to reevaluate our place in the universe and to consider the possibility of a vast and complex multiverse that is far beyond our current comprehension. It's important to note that these are just some of the philosophical implications of multiple universes, and there are many other perspectives and interpretations. The existence of a multiverse is a fascinating and thought-provoking concept that continues to inspire philosophical debate and exploration. The multiverse concept, particularly as proposed by hyperspace theories, has a profound impact on our understanding of the universe's origins. Here's how. 1. Beyond the Big Bang. The Big Bang theory explains the expansion of our observable universe from a hot, dense state, but it doesn't explain what existed before the Big Bang or what caused it. The multiverse concept suggests that the Big Bang might not be the absolute beginning but rather a local event within a larger, multidimensional reality. 2. The bubble universe model. Some multiverse models suggest that our universe is just one of many bubble universes that are constantly forming and expanding within a larger, higher dimensional space. Each bubble universe might have its own set of physical laws and constants, explaining the seemingly fine-tuned nature of our universe. 3. Eternal inflation. Another model, known as eternal inflation, suggests that the initial expansion of the universe, known as inflation, never truly ended. Instead, it continues in some regions, leading to the formation of new bubble universes. This model suggests that the creation of new universes is an ongoing process, potentially happening constantly within the multiverse. 4. Quantum fluctuations and the origin of universes. The multiverse concept also suggests that the initial conditions of our universe, such as the Big Bang, might have been triggered by quantum fluctuations within a higher dimensional space. These fluctuations, which are inherent to the quantum realm, could have created the energy and conditions necessary for the birth of our universe. 5. The many worlds interpretation of quantum mechanics. The multiverse concept also aligns with the many worlds interpretation of quantum mechanics, which suggests that every possible outcome of a quantum event occurs in a separate universe. This interpretation suggests that the universe is constantly splitting into multiple branches, each representing a different possible outcome of quantum events. 6. Challenging the singular point, the Big Bang theory posits a singularity, a point of infinite density and temperature, as the starting point of our universe. However, the multiverse concept suggests that the singularity might not be a true beginning but rather a transition point from a higher dimensional state to our four-dimensional universe. Overall impact. The multiverse concept challenges the traditional view of the Big Bang as the absolute beginning of everything. It suggests that our universe might be just one of many, each with its own unique origin story. This concept opens up new avenues for understanding the origins of our universe and the nature of reality itself. While the multiverse remains a theoretical concept, it provides a framework for exploring the origins of our universe within a broader, multidimensional context.